Hello, my name is Diane Vaudier, and I'm the Product Marketing Manager for the IoT Solutions Group with GlobalSign, a globally trusted, WebTrust-audited certificate authority. Today's webcast discusses the topic of secure device identity for healthcare, from endpoint to cloud. First, a little about GlobalSign. As a leading certificate authority, we operate on a global scale with over 5,000 global partners and 2 global data centers, one in the UK and one in Singapore. We have proven expertise. We have over 30,000 customers who rely on our over 450 worldwide employees to provision and protect their digital identities and TLS servers, enable digital signatures, secure code signing, and more. GlobalSign has issued over 60 million identities, 4 million TLS certificates, and logs over 3 billion online certificate status protocol responses per month. We're a trusted certificate authority, WebTrust audited, and FIPS compliant. Let's talk about secure device identity for healthcare. Of course, any conversation about healthcare security has to first start by understanding the vulnerability that currently exists. Healthcare hacks are on the rise. Data breaches cost the healthcare industry $6.5 million. That's about $429 per patient record. 70% of U.S. healthcare organizations have experienced a data breach, with a third having reported one in the last year. This is the highest recorded rate of any industry. One reason is digital transformation missteps. The majority of healthcare organizations overlooked critical security protocols and encryptions while bringing devices, gateways, and networks online, leaving unsecured areas ripe for attack. So why is healthcare a prime target for cyber attacks? First of all, healthcare deals with some very lucrative personal data, and that's pretty attractive to online hackers. Cyber criminals can earn a higher value per patient record, earning up to $1,000 per record compared to the $1 to $100 for regular financial records. Additionally, patient records contain far more of the individual's personal identifiable information, as opposed to a single marker point. That gives hackers more ways to cross-reference and search for other valuable information. Plus, it takes longer to identify and respond to a hack on healthcare devices, records, or facilities than other types of breaches like credit cards, meaning hackers have a lot more time to do damage and wreak havoc before they're discovered. Second, healthcare has a growing attack surface. It's driven by an aging population and an increase in chronic disease, producing a larger number of people needing care. There are more people using healthcare today than ever before. That is compounded by the medical device industry introducing connected devices and sharing and exchanging health information data. Just like every industry, healthcare is going through a digital transformation and bringing more devices online. So what does healthcare think about IoT security? Are they worried? From what we've seen, not everyone is entirely on board, which can be a bit worrisome. Security costs money, time, and effort. Most times, it's considered a bolt-on process, meaning it's added after the fact, after the devices are connected to the network. Some think of it as simply a compliance problem and include minimum requirements to get by. Commonly, it's lowest on the tier of non-functional requirements and considered a little bit like insurance. So how do medical cyber attacks happen? From our experience, there are 3 main ways: through medical facilities, medical devices, or medical services. Let's take a look at each one individually. First, let's consider medical facility attacks. Research reveals that breaching a hospital network takes only 5 hours. In no time at all, hackers could compromise the entire facility. Medical facilities, or health delivery organizations, manage hundreds or thousands of devices, creating a pretty broad attack surface. Likewise, networks or gateways can be breached, compromising data integrity and privacy. Often the goal is valuable patient electronic medical records, which, as mentioned before, can be quite lucrative. The next area where cyber attacks happen is with medical devices. U.S. hospitals average 10 to 15 connected devices per bed, each a potential entry point. Hackers prefer legacy equipment with older operating systems like MRI machines or CT scanners, but don't always get software updates or security patches, making them more vulnerable. Most of the time, the goal of a medical device hijack or medjack is to establish a backdoor to devices using malware. A big target has been infusion pumps, which can misdispense medicines, causing patients harm. Commonly are used as backdoors to electronic medical records. And lastly, we need to consider attacks on medical services. This includes things like remote patient monitoring and telemedicine. Remote patient monitoring of connected devices can leave devices and their communications open to attack. Telemedicine, the use of electronic communications and software to provide clinical services to patients without an in-person visit, further expands the attack surface. Any medical device has the potential to be hacked, whether it sits bedside in the hospital room, lives in the imaging department, or resides inside the chest of a patient. A great example is former Vice President Dick Cheney, who in 2007 disabled the wireless capability on his pacemaker to protect against personal terrorist attacks. A version of this potentiality was even depicted in an episode of the TV show Homeland, a Showtime drama series where terrorists did, in fact, cause a heart attack on a high-ranking political figure. Although the pacemaker example is quite dramatic, the usual target of cyber attacks are patient information. Most attackers are not interested in causing physical harm, well, maybe except in the movies or TV shows. The biggest targets is electronic medical records for financial gain. Hackers also can create fake IDs to purchase medical equipment or drugs, to file a false insurance claim, or even for corporate espionage by tracking the workings of newly released equipment so they can copy it and add that technology to their own devices. The easiest access point is through devices, including gateways and networks. Because devices are common to all three areas of attack, facilities, devices, and services, standards and regulations tend to focus most on them. Devices in general are beginning to be regulated, with much activity from government, but medical device standards are emerging from non-government bodies as well. States are leading the way with successful device regulation in general. California State Bill 327 took effect January of 2020, requiring all IoT devices sold in the state to be equipped with reasonable security measures. Oregon House Bill contains similar measures. Other standards are in the works. Consumer Product Safety Commission issued a framework for safety for IoT, and the National Institute of Standards and Technology issued a core cybersecurity feature baseline for securable IoT devices, a starting point for IoT device manufacturers. And there's also new proposed legislation. The IoT Cybersecurity Act of 2019 was written to leverage federal government procurement power to encourage increased cybersecurity for all IoT devices. There are some existing government medical device standards already in place. Most are written by the Food and Drug Administration, but Homeland Security and the U.S. Department of Health and Human Services have both contributed in some way to keeping medical devices secure. And there are also some non-government entities contributing to the medical device standards and regulations, such as the Diabetes Technology Society, Underwriters Laboratory, and ISO, the International Standards Organization, have all established some degree of IoT parameters. Even outside the regulations and standards, device manufacturers are finding their own way of fighting back against bad actors with device identity and authentication. Device identities build a network of identity and trust, enabling secure and connected communication. With a unique, strong device identity, devices can authenticate when they come online, ensure secure communication between other devices, services, and users, and prove their integrity throughout the rest of their life cycles. Device identities not only protect devices, but they help to defend the entire supply chain. Manufacturers want to know how they can prove authenticity of their devices. Distributors want to know how to prevent tampering during transport and storage. Systems integrators want to know how they can ensure the software images and keys haven't been compromised. And operators, they're concerned with complying with the local regulatory audit requirements. All these can be addressed with the use of strong and unique device identities for authentication and authorization, as well as PKI for encryption. That's why IoT manufacturers and operators rely on secure PKI. PKI is the de facto credentialing platform for IoT security. It's made obsolete the use of unsecure usernames and passwords. Proper device enrollment is key to provisioning unique, strong, and secure device identities into a PKI, and a registration authority ensures secure device enrollment. So why is PKI the credentialing standard of choice for IoT identity and security? Because security demands that unique devices and things need unique identities. And a public key infrastructure is scalable, can run on constrained devices, regular devices, networks, and gateways, accommodates a wide variety of disparate devices, which hospitals have many, and delivers a means to manage device identities throughout their life cycle. It's also very interoperable. Device identities add secure flexibility. Medical device manufacturers can add identity at various stages of the product lifecycle. For instance, during the design stage, perhaps with secure chips that get embedded into the device, or during manufacture. Medical facilities can add identity at deployment and can manage the device identities throughout their life cycle and even decommission them at the end of their life. Identity is a manufacturer's competitive differentiator. A unique device identity, which is built in during the manufacturing process, moves with the device throughout its lifespan to protect the manufacturer, the supply chain, medical facilities, and even patients. It's the original identifier that enables authentication upon deployment. A hardware root of trust is linked to a device certificate issued by a globally trusted certificate authority and managed by a PKI-based identity platform. GlobalSign's IoT identity platform is purpose-built for medical IoT identity. It combines all the components needed to secure medical facilities, devices, and services. It includes GlobalSign's certificate authority, device certificates with customizable certificate profiles, device enrollment tools, certificate revocation, and an identity database for centralized certificate storage. It's the security backbone of any device identity and management system. What's next in securing devices in healthcare? First of all, devices will undoubtedly move towards standards and regulatory compliance. As new standards emerge and become established, they will be adopted by device manufacturers. Facilities will move towards medical device identity and management. They'll do this either internally with an in-house public key infrastructure or through the emergence of medical device information platforms. Either way, device identity will become an integral part of medical facilities, medical devices, and medical services. Thanks for watching our webcast. We hope you found it helpful in understanding the dynamics and importance of device identity procurement and management in the healthcare industry. Please feel free to contact us if you have follow-up questions or are interested in learning more about how to secure your healthcare devices.